Hi friends, we have a really nice problem. We are given this function f of x equal to greatest integer function of x times sine of something. Okay, what is the domain of this function and what are the points of discontinuity of this function? Okay, this is a product of two functions, this one and this one, right? And sine of something is always defined except when this denominator is not equal to 0. Okay, so when this denominator is equal to 0, sine is not defined because sine of some 1 by 0, sine of some infinity kind of thing. So this cannot be 0. Greatest integer function of x cannot be 0. What does that mean? X plus 1 cannot belong to 0 and 1. Right? When x plus 1 is some 0.5, then greatest integer function of x plus 1 will be 0 or 0.1, then this part will become 0. So x plus 1 cannot belong to closed interval of 0 and 1, right? Right, x plus 1 cannot be 0 also. X plus 1 cannot be any number lesser than 1 and lying between 0, even if it is 0.9, right? X plus 1 is 0.9, then also greatest integer function of x plus 1 is actually equal to 0. What does that mean? X cannot lie between minus 1 and 0. Again, same, this close bracket, 0 minus 1 is minus 1, 1 minus 1 is 0. Same thing, x cannot belong to this set. What does that mean? X can belong to everywhere else. That means minus infinity to minus 1, open bracket, union, close bracket, 0 to infinity. Right? X can belong to anywhere like this. X can belong to anywhere like this. Right? Minus infinity to minus 1, both open brackets, because if it is x equal to minus 1, then clearly this is not possible, right? If it is minus 1, then this becomes minus 1 plus 1, right? This becomes 0, which is not possible. At the same time, 0 can happen, right? X can be equal to 0. So because 0 plus 1 is 1, that should be fine. So this is the domain. The domain is minus infinity to minus 1, both close brackets, and 0 to infinity, 0 open, 0 close brackets. Here both open brackets, and here 0 is close brackets. Fantastic. Now the domain part is clear. Now when is this function discontinuous? Okay, so let us try to understand by some segments. Okay, let's say we take 0 to 1. Okay, in this domain 0 to 1 is a point, right? 0 to 1, this one will be 0, greatest integer function of x, that is 0. Then sine of 5 by 0 plus 1, this is 1, right? So this is actually equal to 0. That is fine, right? And between 0 to 1, this is actually equal to 0. So if you have to draw the graph between 0 to 1, this is 0. Graph is 0. This point is, let's say, 1. Now let us check for 1 to 2. 1 to 2, what will happen? This part will become 1 sine, and this part will become pi by this one. Between 1 to 2, right, x can be 1, and x can be 1.1, x can be 1.7, whatever. So this part, greatest integer function of x, this would be equal to 2, greatest integer function of x plus 1, right? X is 1.1, 1.1 plus 1. This one is actually 2.1, greatest integer function of 2.1, which is equal to 2. Similarly, 1.9 plus 1. This is also equal to 2.9, greatest integer function of 2.9, which is still equal to 2. So as long as x is lying between 1 and 2, this part will become 2. So 1 sine pi by 2. What is 1 sine pi by 2? This is equal to sine pi by 2 is 1. This is 1. So between 1 and 2, this is actually this line. Okay. What happens between 2 and 3? This part is obviously 2. 2 sine pi by, again, this part. A number between, so we are talking about between 2 and 3, right? Between 2 and 3. This number is always greater than 2, but, sorry, this number is always greater than 3. 2 plus 1 is 3, greater than 3, greater than or equal to 3, but lesser than 4. So obviously, greatest integer function of this is actually 3. 2 sine pi by 3. What is sine pi by 3? Sine 60 degrees. That is roughly root 3 by 2. 2 times root 3 by 2, which is equal to roughly 1.7. So this is 1. This is somewhere 1.7. between 2 to 3. Right. So basically, this graph is like this. At 1 there is a break, at 2 there is a break, at 3 there is a break. So next point line would be somewhere like this, and next line would be somewhere like this. Likewise, between 0 and minus 1, this is not even defined. Right. Right. This graph basically it breaks at every integer. Okay. Let us try to understand how it looks. For example, 0 to 1, it is like this. 1 to 2, we have figured out it is 1. Right, we have figured out 1 to 2 is actually equal to 1. 2 to 3, we have figured out it is 1.7. That is this one. That is root 3. Right. And 3 to 4 is even slightly higher. And 4 to 5. 4 to 5 is something higher. 5 to 6 is something even higher. Okay, so 5 to 6 also. Let's try 5 to 6. X sine 5 by x plus 1 greatest integer of function of x. What is this one? Between 5 to 6. Between 5 to 6, this part is actually 5. 5 sine 5 by this part will always lie between 6 and 7. Right. Always lie between this and 7. So that's why this sine 5 sine 5 by 6, which is nothing but 5 sine 30 degrees, which is nothing but 5 times 1 by 2, which is 2.5. So this line is actually, if you can see, this is actually 2.5. Right, 2.5. This line is actually. Right. So this graph is actually moving like this. It breaks at every integer. Okay. So the points of discontinuity are every integer it is breaking. Between 0 and minus 1, we cannot even define. What happens between minus 1 and minus 2 and minus 1? Minus 2 and minus 1. Basically, this part will be equal to minus 2. Minus 2 sine 5 by some x plus 1, because we are talking about x plus 1 will lie somewhere in this range. So this one is pi by minus 1. Right, greatest integer function of x plus 1 is pi by minus 1. So for example, if you are talking about minus 1.5, minus 1.5 plus 1, which is equal to minus 0.5, which is equal to minus 1. Right, minus 2 sine pi. 2 sine pi, 2 sine pi or minus pi. 2 sine pi is anyway 0. So that's why it is like this. Right. Similarly, minus 3 to minus 2, you can show that it comes out to be plus 3. Okay. This graph of this function. Okay. So now it breaks at every integer. At the same time, let us try to understand this graph of sine pi by x minus 1 or pi by x plus 1. Okay. First of all, sine x or sine 1 by x. Earlier we have discussed sine 1 by x. Sine 1 by x we had discussed. It looks something like this, because as 1 by x, as x tends to infinity, 1 by x tends to 0, so the graph will go closer to 0. Okay. But as x comes closer to 0, right, 1 by x varies a lot, so that's why it fluctuates a lot. Basically, sine 1 by x graph is this graph, when this is y-axis and this is x-axis. Okay, sine 1 by x will look something like this. But this is sine pi by x. Right, sine 1 by x versus sine pi by x. What is sine pi by x? It is compressed pi times. Right, sine 1 by x would look little more relaxed. Right, little more stretched. But sine 1 by x is little more stretched than this graph. Right, this part would be little more stretched. But now sine pi by x is actually compressed version of sine 1 by x, but overall the structure will look similar. Right, this is sine 1 by x, sine pi by x graph. Now sine pi by x plus 1. Right, what does that mean? This graph is shifted 1 unit towards the left. Right, whatever this concentration was at 0, this was shifted 1 unit towards left. Right, f of x plus 1 is f of x shifted 1 unit towards the left. So that's why this graph is like this. Right. So this graph, this red graph is sine pi by x plus 1. Okay. So obviously when x equal to 0, what is happening? Sine pi, the value of this function is sine pi. That's why this is 0. When x equal to 1, what is happening? Sine of pi by 1 plus 1, which is 2. Sine pi by 2 is 1. Right. Similarly, this. When x equal to 2, it is sine pi by 3, 0.8 something. Pi by 4, pi by 5, and pi by 6. Right. Pi by 6 is what? Half. Right. Sine of pi by 5 plus 1. Sine pi by 6 is equal to sine 30 degrees, which is actually equal to half. Right. Now, because we are putting this greatest range function here. So that's why this entire part will be taken. Instead of this one, we are taking between 1 and 2, that will be this graph. Sine of this one will be between 1 and 2, that will be this graph. Between 2 and 3, ideally it should have been this graph, but we are multiplying with this 2 again. So double of this, right? Which is, this is some 0.8. This one is double of it, which is 1.7. Similarly, 3 times of this line. 3 times of this line is actually this line. Similarly, 4 times of this line, this point, this line is this. Similarly, 5 times of this line, 5 times of 0.5. This is equal to 2.5. 6 times of this line is actually this one. Likewise. Okay, guys. So this is how we should thoroughly understand the graphs of functions. Rather than just knowing the answer is fine, but we should thoroughly understand how each function behaves, so that we have better understanding, and any complex questions also we should be able to answer. So we started with sine 1 by x graph, which is a very familiar graph that we know, and then we compressed it with pi times, that is some compressed version, and then we shifted 1 unit towards the left, right? That's how we arrived at sine pi by x plus 1 graph. But this graph is not even needed to solve this question, because just by substitution itself we can say between different integers how this function is continuous or discontinuous. Right, guys? Thank you.